Time for some math. So our last kind of topic before you get ready for your third quarter final exam, graphs, sine, and cosine. Yesterday we did amplitude and we did period. Today we add in the horizontal shift and we add in the vertical shift. This is the most important lesson for the unit. If you can understand today's lesson, you have an excellent chance at getting 100% on this next test. Taught it many times, many times, and generally people do very, very well with this concept, okay? Doesn't mean it's easy. Today we gotta work through that confusion, and we will hopefully get it figured out. If you have an equation of either of these forms, the period is the absolute value of A. I'm sorry, the amplitude is the absolute value of A, just like we talked about yesterday. The period is the same as well. It is 2 pi divided by, do you remember what value? B. If you remember when we talked about transformations of functions, we said if it's on the outside, it affects it vertically, and if it's on the inside, it affects it horizontally. So this plus d on the outside, that is going to be the vertical shift. So that's pretty simple to just see that one piece. The very last piece is the horizontal shift. That's just a little bit more confusing. We set bx minus c, or the inside, equal to 0, and we solve for x. Again, if you were to look at that sheet of notes that I gave to you for the parent graphs, you can see that that sheet of notes contains all this information under the sine and cosine section. It tells you how to find all of those pieces. And again, that's what you get to use on this test for the final, as well as your next test. So let's try a couple examples. So we're going to start with example B. Okay. When I look to graph these, instead of starting with the amplitude, I actually start with the vertical shift. Then I do the amplitude and the period. Okay? I do the horizontal shift last. So start in that order. So the vertical shift is going to be the number that's added or subtracted onto the end. So what is the vertical shift in this scenario? 2. So what that means is instead of the graphs kind of going up and down about the x-axis, is it's going to go up and down about the line y equals 2. So it's going to rotate on that. Okay. What is the amplitude? 3. What we do is when we identify the vertical shift, we draw an axis of rotation. Draw an axis of rotation through vertical shift. And that's what I did. I drew my axis through the vertical shift. The second thing is when I identify my amplitude, I take the vertical shift and I add and subtract the amplitude. And that will give me my max and my min. So I'm going to mark my max and min. Nope. So the amplitude will be the vertical shift, when we figure out the amplitude, we take the vertical shift plus and minus the amplitude. So I'll show you what we do. What is the vertical shift? 2. So I will add 3 and subtract 3. When you add 3 onto 2, you get, so that will be the maximum value of your graph. Then I will do 2 minus 3, and I get -1. you can see that I took the vertical shift and I added and subtracted the amplitude in order to get my maximum and minimum values. Because the graph is centered at 2. So if it goes up 3, it will be up to 5. If it goes down 3, it will be down to negative 1. Make sense? Okay. Period. 2 pi divided by, what's the number in front of x? 1. Period is 2 pi. We divide into how many parts? 4 parts. Why 4? 4 quadrants. Yep, very good. So I will mark off 2 pi. I have a little bit of space over here, so because we practiced this yesterday, I'm going to at least put 2 of these spots over here. Again, the worksheets I give you, this is more centered, so you can do a full period on both sides. I apologize, I forgot to change the notes to serve that purpose. All right. At this point, we will always sketch a graph. Okay? We will always sketch a graph. But first, I'll look ahead. Is there a horizontal shift? Is there anything special on the inside here, like I have here? No. So there is no horizontal shift. Even if there was, you would still sketch a graph. And I'll show you why we do that in a second. Okay? So let's sketch this graph. Cosine, does it start at the max, min, or middle? So it's going to start at the max. Cosine starts at the max or the min because it's positive, starts at the max. And then instead of crossing over this spot, it will cross over its axis of rotation. And then it will go all the way down to, what's the smallest value it will reach? All the way down to negative 1. And then it will come back up. Top up. And I can do the reverse order on the other side. So yesterday we knew how to do these type of graphs, but what we did was we just did the amplitude and the period. So this is the same type of graph, it's just shifted vertically 2 units. That's all the new learning for today. But we haven't looked at one with a horizontal shift yet, or fold. So those are the next examples that we're going to do. We start here, vertical shift. Do you see any number on the end here that's being added? So there's no vertical shift. The amplitude is the absolute value of the number in front. 1. The period is 2 pi divided by the number in front of x. So we get 2 pi. And the horizontal shift, we will take the inside and set it equal to 0. So x minus pi over 4 is equal to 0. What do you get? What is x? Pi over 4. So I actually figured out all 4 of my pieces, but let's go ahead and start to put them together. Vertical shift of 0, so it's centered right along the x-axis. So like here, I moved up to the blue line. I don't need to move it up or down at all. I'm good to go there. The amplitude is 1, so I'm going to go up 1 unit, and I'm going to go down 1. I just choose to decide how big I want to make that. The period is 2 pi, so I'll mark 2 pi, and I'll divide it up into 4 parts. marked off the vertical shift, the amplitude, and the period. At this point, you will sketch a graph before you do the horizontal shift. What I do is I sketch a ghost graph. And what I mean by ghost graph, it's not the actual graph. It's a dotted line that's going to help us then sketch the real graph. So where does sine start? Max, min, or middle? Middle. And will it start by going up or by going down? It's going to go up, down. And I just dot it because it's not the real graph. I'm just going to use it to make the real graph. I'm now going to apply my horizontal shift. Try again. So what we want to do is we want to take that graph and we want to shift the whole thing over. It's not going to let me do that. That's okay. I'm actually going to drag it back over. All right, let's do that. Okay. So what we want to do is we want to literally pick that graph up and we want to shift it. How many units? Pi over 4. How much is pi over 4 compared to 1 tick mark? Half of a tick mark, right? If this is pi over 2, then halfway between would be pi over 4, correct? So what I'm going to do is I'm going to take all of these special points and I'm going to move them over a half of a tick mark. Now that I move them all over a half of a tick mark, I can then go ahead and sketch my real graph. And by looking at it at the end, it's not perfect, but I can be pretty confident that that's a very good representation of my graph. I can see that it shifted over pi over 4 units. Right? What do you think? So the horizontal shift is generally the most challenging part for people. If you can do the next two examples, those are by far and away the hardest examples that you would see us cover. And you will not get an example that difficult on the test. Okay? So if you can do this, you are A+ set to go. Alright? Let's try the next one. Vertical shift. -2. Amplitude. 4. So, as I mark this off, I'll do -2 plus 4 and -2 minus 4. What's -2 plus 4? 2. What's -2 minus 4? -6. So that means I have to go all the way up to +2 and all the way down to -6. So I'm going to call this -6. Let's call this +2. And this is my vertical shift, my axis of rotation, which is -2. So I just took care of the first two parts of graphing this function. That wasn't too bad, was it? The period isn't too bad because we did it yesterday. We realized it's not as challenging as what it may seem. So I take 2 pi and divide it by what's the number in front of x? Pi. People say, well, that's a variable. No, it's not. It's a number, 3.141. And I get pi, or a period is equal to 2. So I'm going to divide that up into 4 sections. What's half of 2? 1. What's half of 1? We got 3 halves. -1/2, -1/2. Okay, I have those taken care of. Is there a horizontal shift? Yes, there is. Should we sketch a ghost graph right now, or do you want to figure out what the horizontal shift is? Doesn't matter. Okay, let's figure out the shift. Take pi x minus 1 and you set it equal to 0. Take whatever that inside piece is and you set it equal to 0. Somebody tell me, how do I solve that? Add 1, so pi x is equal to 1. Then divide by pi. X is equal to 1 over pi. Do you see anything up on your x-axis that has a pi in it? So it would be more helpful if this was a decimal, wouldn't it? If you take 1 divided by pi on your calculator, you get approximately 0.3. So as you look at your graph here, how does 0.3 compare to a tick mark? Is it more than one tick mark? Is it less than one tick mark? A little bit more than a half of a tick mark, right? Point or one half is what is a decimal? 0.5. We're at 0.3, so it's a little bit more than half of a tick mark, right? So that's what we'll move it. But first, let's sketch our ghost graph. This is cosine, max, min, or middle. If you want to start the max or the min, because it's negative, it will start at the minimum, which is negative 6. From there, will I go up or down? I'll go up. You're at the minimum, so there's nowhere to go but up. Here's my ghost graph. What I need to do now is take all of these and move them a little bit more than half of a tick mark. I need to move them 0.3. One tick mark is 0.5. Try to move it a little bit more than a half. And this is not an exact science. You guys know we're sketching these by hand. No, I do not really have any handy graph paper for this. We just need to really try to be neat and do our best. What do you think? Do you think we're accurate? Like, do you think if I graphed on a calculator, what kind of grade would you give me? Scale 1 to 10. 9? Oh, I like that. I'll just to show you so you can appreciate it. You don't have to do this, but I will pull this up on the calculator real quick, and you can check to see it and see kind of what your thought process is. I go to y equals. I'm going to take up my my graph here. I'm going to type it in. -4 cosine of pi x minus 1 minus 2. And if you're graphing them, you're always supposed to be working in radians. And when I set up my window, I'm just going to look from -6 to +6 for my y value. You can see that I have a tick mark every 2. And for my y values, it looks like I go all the way over to +2, and I start back at -1. And I have a tick mark every 1/2. So let's see how well I did. That's a pretty accurate representation. I would say so. At the beginning of the year, I showed you guys that we would have to graph that someday. And the eyeballs just about fell out of your face. So, like, there's no way I'll be able to do that. We just did that, no big deal. We did it just as well as you calculated. Okay? You should be impressed. You should be like, yay, wow, I'm smart. You are smart. Way to go. Alright, we do the last one. Negative sine of 2x minus pi over 2 plus 3. Okay, what is the vertical shift? What is the amplitude? Anybody have any question on how I came up with either of those two values? Okay, we do 3 plus 1 and 3 minus 1. What do we get? 4 and 2. So this one is going to go all the way up to 4 and down to 2. And 3 is my axis of rotation. So tell me, will this graph ever cross the x-axis? No, it won't. It always stays above the x-axis. Will this graph ever cross the y-axis? Yeah, it will. So the vertical shift 3 is going to be your line that goes across. That's the vertical shift. Okay, now let's figure out the period. The period is 2 pi divided by 2. That gives me pi. So my period is pi. Mark it off, pi. It's pi divided in half. 2, divide that in half. Now we count. 1 pi over 4, 2 pi over 4, 3 pi over 4. Go back up. Grab those first two. And I just chose those two because my graph is centered off to the side. It's the way I used to do it. But on your worksheets, I'll put the center. And you'll just copy the same thing. Good question. Okay, so the horizontal shift, we'll figure that out. But we'll have to make a ghost graph first. I take 2x minus pi over 2, and I set it equal to 0. How do I solve that equation? 2x is equal to pi over 2. If I divide by 2, I can divide by 2 over 1, or multiply by pi over 2 times 1/2 is pi over 4. Pi over 4 is my horizontal shift. How much of a tick mark is pi over 4? It's a whole tick mark. So we're going to move everything one full tick mark. Okay. Let's make our ghost graph first. This is a sine graph. Will sine start at the max, the min, or the middle? The middle. And will this sine graph start by going up or by going down? It will go down. The bottom value will be at 2. We'll have to go back up. Maximum value. Oops. Maybe I should just make a dotted graph. It's not my real graph. Now I can make my real graph. I shift everything one tick mark, pi over 4. All these points move over one tick mark. Anybody worried about how neat their graphs look? Okay. Here are some things that I want to make sure you understand that you should do for your graphs. Please, number one, don't do that because they don't come to points. They are smooth curves. And then second of all, that's supposed to be the curve, something like that, you draw it like that. That that gets a little lazy. I won't. I'll take some points off on the test for that. This year I haven't had to take any points off yet between the two different trig classes I taught for sloppy graphs. But last year I did. So if I can't understand the graph, and I work pretty hard to understand what you guys write down, I can't give you full credit for it. So I'll write this on the test, and I'll maybe do the same for you. So hopefully nobody's drawing one that looks that bad. So again, if I go back to my previous example, um, I'll again in green. You don't want to do this. You don't want to do the real etched ones. And then in black, if I were to draw it like this, that's not a good enough graph. Okay, not good enough. So just heartbeat monitor exactly. Try to be careful. Okay, so are you getting a worksheet today? What do you need to work on? Study guide and your worksheet from yesterday. So that will take care of all the content that you have for your final exam. Three big ideas. Find the exact values of sine, cosine, and tangent. Graphing sine and cosine. And solving right triangles. Those are the three things that we really want to focus on for the final exam. The most important parts of trigonometry thus far.